Calculus, AB homework 1.7. This is using the intermediate value theorem. Number 1, determine using the intermediate value theorem, that really should be capitalized, if the function f of x has a 0 on the interval from 0 to 1. Justify your answer and find the indicated 0 if it exists. Well, for the intermediate value theorem to work, first of all, f of x has to be continuous on the interval that we are referring to. And since this is a cubic function, it is, so we can just say f of x is continuous on the interval from 0 to 1. And then part 2, we got to figure out is the y value that you get when you put a 0 and a 1 in for this. Are those y values, one of them bigger and one of them less than 0? So let's see if we can figure that out. So what is f of 0? These should be capital F's because this function here was named capital F. Does matter. So little f will be a different function. So what is f of 0? Well, if you put a 0 in for this, we're going to get 0 cubed plus 2 times 0 minus 1. That's going to be negative 1. What is f of 1? That's going to be 1 cubed plus 2 times 1 minus 1. That's going to be 2. So then the question we want to ask ourselves is f of c, which in this case is 0 between f of 0 and f of 1? In other words, is the number 0 between negative 1 and 2? It sure is. So we would say that f of 0 is less than f of c, which we want that to equal 0, which is less than 2. Therefore, the intermediate value theorem guarantees a value of c on the interval (0 to 1) such that f of c equals 0. So what we got to do to figure that out is we have to take this and set it equal to 0. Wish I would have written a little smaller. So if I set 0 equal to this, and I'm putting a c in for this, since this is a calculator problem, I am permitted, this tells us the calculator problem, I can put this into y1 and look and see where this crosses the x-axis, specifically where it crosses between 0 and 1, by doing second calculate 0, and I would find that this is about 0.453. Finished. Number 2, same thing, different function. Is theta squared continuous? Yes, it's a quadratic. -2 is continuous, it's linear. Cosine of theta, that is continuous. The addition or subtraction of continuous functions is going to also be continuous. So part 1 we could say g of theta is continuous on the interval from 0 to pi. Now we got to figure out what are the y values of this when we put 0 in for theta and when we put pi in for theta. So part 2, got to figure out what the n values are, g of 0 and g of pi. G of 0 is going to be 0 squared minus 2 times cosine of 0. Cosine of 0 is 1. So that's going to make this negative 2 minus 1, which is negative 3. If we put pi in for this, we're going to get pi squared minus 2 minus a negative 1, which would be like a plus 1. So let's see here. This is going to be pi squared minus 1. Since we can, before we continue, clearly this is negative, this is going to be positive. And we want to know if a 0 exists. That's when y is 0. The number 0 is between negative 3 and whatever this is. We could figure out what that number is if we wanted to a certain number of decimal places. We're going to round to 3 decimal places in AP Calculus. So if you wanted to know what that is, it's 8.870, looks like. So the intermediate value theorem is going to apply because g of theta is continuous on this interval. The y value that we are in search for, which is 0, is between negative 3 and this. So g of 0 is less than g of c, which is 0, which is less than 8.8, I don't want to say that, which is less than g of pi. So therefore we can say the intermediate value theorem guarantees a value of c such that g of c equals 0, and I left off my interval. Guarantees a value of c on the interval from 0 to pi such that f of c equals 0. Now to find that value, we're going to take function g and set it equal to 0. And we're going to replace the thetas in this with c's. To figure out what that solution is, this is a calculator problem right here. So we're going to put this into y1, find the 0 of the function that's between 0 and pi, and I believe that you will find that to be 1.455 approximately. Alrighty. For exercises 3 through 5, those are the last 3 problems. Verify the intermediate value theorem is applicable for the given function on the given interval. Then, if it is applicable, find the value of c guaranteed by the theorem. It's the same directions that we just had, essentially. First of all, is this function continuous on this interval? You betcha it is. It's a quadratic, and quadratics are continuous every place. Second of all, we got to figure out, is the y value you get at 0 and the y value you get at 3, is one of them bigger and one less than 0? F of 0, we can see if we put 0 in for this, we're going to get 0 minus 0 plus 8. It's 8. F of 3, it's going to be 3 squared minus 6 times 3 plus 8. It's going to be 9 minus 18 plus 8. Let's see, that's going to be a negative 1, I believe. We want this y value of 0 to be between these, and they are. So we could say that f of 3 is less than f of c, which is 0, which is less than f of 0. So our conclusion then is, therefore, the intermediate value theorem guarantees a value of c on the interval from 0 to 3 such that f of c equals 0. It's not always 0, but that's what it was in this problem. We were not told we could use a calculator for this. So we set c squared minus 6c plus 8 equal to 0. I just took this function, set it equal to 0, and replaces the x's with c's. This factors into a c minus 8, no, c minus 4, and a c minus 2. We're going to get that c is 4 and c is 2 for this. However, we're looking for numbers on this interval from 0 to 3. This is not on the interval. Therefore, we're looking for the value of c equals 2. Cool. Number 4, we can use a calculator for this one. And I'm going to show you the true power of using a calculator. So this is on the AP test. You were given this problem. It was in the calculator section. This is the work that you would have to do, and you will find that it's not a ton of work. 1, is a cubic function continuous? It sure is. So we say g of x is continuous on the interval in question, which is 0 to 3 inclusive. 2, well, what is g of 0? What is g of 3? And are those y values one bigger and one less than 4? Well, using my calculator, so I can just go ahead and put into y1 this function, and then I can put a 0, like I could use the table and put a 0 in for x, or I could look at the graph and say, second calculate value 0. I'm going to get negative 2. If I put a 3 in for this, using my calculator, I'm going to get a 19. Notice there's no other work to show for that to get credit on the AP test if you're allowed to use a calculator. And then we want to know, is 4 between these y values? Sure is. G of 0 is less than g of c, which is 4, and that is less than g of 3. Therefore, the intermediate value theorem guarantees a value of c on the interval from 0 to 3 such that f of c is 4. Now to find that value, we are going to set 4. Tell you what, just to make sure that I'm not jamming stuff together. Going to set 4 equal to this function, replacing the x's with c's. And then we could get 4 on the right side of the equation. And then you could put that in your calculator. You'd use x's, not c's. Put it into y1, put it into y2, put it into y whatever. And then find the x-intercept of this. It's between the interval from 0 to 3. And I believe that you will find that is at c equals 2. Another way that you could do this, if you want to go a different route, you can put this into y1, this into y2, and see where they intersect each other. And make sure that you only care about the intersect between 0 and 3. You would also find that it's 2. Last one, number 5. This is a non-calculator. So we got to show all the algebra work for this. Well, first of all, is this graph continuous? Well, it's not continuous at 1. There's a vertical asymptote. But 1 is not in this interval. So h of x is continuous on the interval 5/2, 4. So we're cool there. 2, we got to figure out what's the y value if we put 5/2 into this, and what's the y value if we put 4 in for this. We want one of those answers to be bigger than 6 and one to be less. So 5/2, we've got to figure out what h of 4 is. H of 5/2, we're going to have 5 over 2 squared plus 5 over 2 over 5 over 2 minus 1. 5 over 2 squared is 25 fourths. I'm going to change 5/2 to 10 fourths, so I have common denominators. I'm going to do the same on the bottom. I'm going to get common denominators on the bottom. I'm going to make sure it's a 4 as well to make this easier on myself. I'm going to have 10 fourths minus 4 fourths. That's going to give me 35 fourths over 6 fourths. If I multiply this by 4 over 4, I end up with 35/6. If I put 4 into this, I'm going to get 4 squared plus 4 over 4 minus 1. That's 16 plus 4 over 3. That's 20 thirds. I feel like I may have made a mistake someplace. All right, I'm cool. So the question is, does 6 fall between these two fractions? Well, 35 over 6 is less than 6, because 6 times 6 is 36. That's less than this number. 3 goes into 20 6, like more than 6 times, but less than 7 times, so 6 point something. So that tells us that h of 5/2 is the smallest number here. It's going to be less than h of c, which is 6. And that's going to be less than h of 4, which is 6 point something. So the intermediate value theorem applies to this. It guarantees a value of c on the interval, closed interval, 5/2 to 4, I mean open interval. It does not include the numbers, the endpoints, such that f of c is 6. So what we're going to do is we're going to figure out what the c value is. We're going to take c squared plus c over c minus 1. That's this function, replace the x's with c's, and we're going to set it equal to 6. If we multiply both sides by c minus 1, we're going to get c squared plus c equals 6c minus 6. If we get all the terms on the same side by, let's say, adding 6c subtracting 6c and adding 6 to both sides, then this factors c minus 6 and a c plus 1. We would get a solution here of c is 6 and another solution that c is negative 1. No, we would not. If we multiply those, we get a negative 6. I did not factor that right. How about c minus 3 and c minus 2? If you add those, you get negative 5. If you multiply them, you get 6. That's better. So here we're saying that c could be 3 or c could be 2. Are both of those on the interval that we're talking about? 2 is not, because this is 2.54. So this is not our solution. Our solution is c equals 3. It's in the interval. All right, that wraps her up.